Limits. So what does a limit mean to you? I'll tell you an example from real life and then we'll get on to actual mathematical definition. So suppose you're driving on a highway, okay, and you've seen these signs on the side of the highway which says 90 km/h. So what does this mean? It means that the speed limit in that road is 90 km/h. So you see these cars, let's just assume these are cars because I'm bad at drawing. That's one car, there's another car here, there's a motorbike here. Alright, they're all moving forward, but this car is moving at 65 km/h, this is moving at 80, and this motorbike is going at 50 km/h. Alright, so none of these vehicles have reached 90. Then why is there such a speed limit on this road? Is it meant that all the vehicles should travel at 90 km/h? Of course not, because then the risk of accidents will be very high. Okay, so what does 90 actually mean? 90 is a limit. So we can drive, suppose this car accelerates up to 85 and then goes up to 18.7, and then ahead he sees a traffic light, a signal, so he has to slow down because it's on yellow and it'll eventually turn red. So he has to slow down. He slows down from 87 to 60 to 50 and eventually to 0 pretty fast. Once the traffic light becomes green, he can accelerate again and go to his former 80 km/h, then increase up to 87, but then he just sees some congestion of cars ahead, so he has to slow down again. So what does this say? No one was actually meant to drive at 90 km/h at a constant speed. We just know it's a speed limit. Speed limit means that's the maximum speed you can go, but no one was actually meant to attain that speed. So in mathematics, such a limiting factor is called limits. I'll tell you. And this is especially used in the case of functions. We've learned functions in the previous classes. What is a function? Function can be denoted by f of x, and it will have an input x and it will give an output f of x. Okay, so suppose we have a function f of x equal to 2x. Okay, f of x equal to 2x, and we have our speed limit. Suppose f of x is the output, and suppose the speed limit was 6 on a particular road. The speed limit was 6. Okay, and we give the value of x 3. So if x was 3, we can reach the speed limit 6. So 6 is our speed limit. Suppose we give the value 2.9. What will our f of x be? Our f of x will be 2 into 2.9, which would be equal to approximately 5.8, right? 5.8 is really close to the speed limit but hasn't actually attained it. Now I'll give another value to 2.9. The x we give 3.1. 3.1 is also same, as much as close as 2.19 is to 3. 3.1 is same distance away from 3 because both are distance by 0.1 units. So f of x would be, in this case, 6.2. This is also 2 units away from the speed limit. So when suppose we give x equal to 2.999, this is really close to 3. So what will f of x be in this case? It will be 5.9980. So this is really close to 6. It's closer than how 5.8 was. So we can see as x moves closer and closer to the number 3, f of x goes closer and closer to the speed limit, which is x 6. Okay, so such an idea is involved in limits. Suppose we can express the limit in the form limit, we write lim or lt, some people write lt, I'll write lim for limit x tends to a number, suppose we can call it a, and we have our function f of x. There's two ways of reading it: limit of f of x as x approaches a, or limit x tends to a for function f of x. So this clearly does mean, so what did we do in this case? We limited limit as x approaches our number 3 for the function f of x. We get our answer as 6, right? It becomes closer and closer to 6. So we can solve this, we can solve limits by pretty simply limit x tends to 3. What is f of x? F of x was our 2x. To solve a limit, we just apply x tends to 3 here. So instead of x, you write x tends to 3. So x is pretend x is equal to 3. Even though it's not equal to 3, pretend x reached 3. So we have to pretend x reached 3. That would mean 2 into 3, which would equal to 6. So we have to know when an input approaches a value a, what would be the output of this. The output is what we have to know in mathematics. So in mathematics, a limit helps us understand what value a function is approaching as the input gets closer and closer to a certain number. So as this input x approaches a certain number a, we have to know what the value of the function would be. So in a real life situation, as we get close, if we approach the speed limit or higher, our risk of accidents is higher. So we know as speed tends to the speed limit 90, accidents tends to be really high. In the same case, as the input tends to a number, we can find the value of the function that it tends to. And in this case, we can say it tends to 6. You're wondering why do we actually need limits? Like if we were to just find what would happen at x of 3, we can just put it in this function f of x equal to 2x and just find out it's 6. So as we approach 3, f of x would be 6. It's pretty self-explanatory. So limits are needed because of two functions. We already told the function. In many functions, we want to know what's happening just before a certain point. So if we give x equal to 2.999, we get f of x as 5.9880. Alright. So as x tends to some number right before that number, we have to know the value f of x equal to 5.988. That's why I use limits. And the second reason, some functions are not even defined at a point, but a limit can still exist. I'll give you an example for a function f of x equal to x square minus 1 divided by x minus 1. So this is a rational function. So what is the addition of rational function? The denominator cannot be equal to 0. So which case will denominator be equal to 0? X is not defined at 1, but x can be 0.999, which is really close to 1, or x can be 1.0001. This is also really close to 1. So here, if these numbers were to exist, this function would still exist, but at a point 1, this function would not exist. So we can write this in the form of limit x tends to the number 1, then what would be the value of f of x? That is what we have to find. But we cannot directly apply 1 because 1 minus 1 would be 0 and denominator would get cancelled out. So limit x tends to 1, we write the actual function x square minus 1 by x minus 1. Okay, and we can see what is x square minus 1. We can pretend 1 was 1 square. A square minus b square is equal to a minus b into a plus b. So we can factorize this a little bit. X minus 1 into x plus 1, which would be x minus 1. We can cancel x minus 1 and x minus 1. It will be limit x tends to 1 x plus 1. So x plus 1 is our resulting function. Now we can directly apply x tends to 1 here. So if x was equal to 1, we can write 1 plus 1, which is equal to 2. So the answer will be 2. As x tends to 1, f of x will tend to 2. But here we couldn't know that, because if we applied 1 here, this would just give an undefined result. But using limits, we found the value of f of x as x tends to 1.